Okay, welcome to Chapter 11. We start out with Chapter 11 because we start out with gathering data. So in your book it is Chapter 11. And for the first day, what we're going to start out with is what is simulation and how do we use it? Simulation, simulating. If I want to simulate something happening, I can probably do that a lot cheaper than actually doing it in real life. So for example, if I wanted to simulate the chance that a Ferrari would get in a crash, I'm not going to go out and take a Ferrari and see if it crashes. I'm going to simulate it. If I'm going to simulate the probability of batteries running out, so that way I have no water and no telephone and no electricity in the wild, I'm not going to go out there and wait till the batteries die. I might simulate the chance that the batteries will die. So there's a lot of use for simulation in statistics, but what you have to think about, or what you have to learn about, is the components of simulation and how do you perform one. So simulation is just the process of using random numbers to simulate a situation, but there's some components to it. First thing, you got to identify the component being repeated. What is it that you're doing? Okay? So let's take a scenario. Let's say, when I was a kid, Happy Meals were big and they had little prizes inside. And I always wanted to get a certain prize out of a Happy Meal, okay? So if I'm going to simulate like how many Happy Meals I have to buy to get a certain prize, I'm not actually going to go there and buy Happy Meal after Happy Meal after Happy Meal, because it used to be random prizes. I might simulate, okay, how many Happy Meals I would have to buy, okay? So, for example, the component being repeated, purchasing a Happy Meal and seeing what toy is inside. When I simulate, that's what I'm simulating, the fact of the simulation of purchasing the Happy Meal. So, simulation then allows me to perform the task over and over again, purchasing a Happy Meal, without actually purchasing it. I'm just simulating it. Next is explain how I will model the outcome, okay? How am I going to model this outcome? So what's going to happen is I have to explain, how am I going to go through the process? What does a simulation look like, all right? So explain how you model the outcome. So how are you going to assign numbers to the different outcomes? So we're going to use a random number table like we use today in class. And I have to assign numbers then, okay? And so let's say there's 5 toys in a Happy Meal I could get. I can use numbers to simulate getting each of the different toys. So for example, I could let the number 1 be the first toy, 2 be the second, 3 be the fourth, 3 be third, 4 be fourth, 5 be fifth. Look at the random table, and if I come up with a number like 6, 7, 8, 9, or 0, I would have to skip it. And so when I'm talking about assigning numbers, I have 2 goals in mind. One, the proportion of the numbers that I assign to a given task have to match its proportion that it represents in the situation. So if I have 5 toys and they're equally represented, how many numbers I give to toy 1 has to be the same number of numbers I give to toy 2, 3, 4, and 5. So I could give them each all 1 number, and that would work, even though I'm not using up too many numbers. Well, 5 goes into 10 nicely by 2. So really what I could do is I could let the numbers 0 through 1 represent getting the first toy, 2 to 3 getting the second toy, 4 to 5, 6 to 7, 8 to 9, and so on. And so in the back of that table that we used today, you will see a bunch of numbers. I'm going to look at them 1 digit at a time, okay? And whatever number I get is the number that would represent a toy. So for example, if I look at our table that we use, I have to pick a line in that table. So let's say I pick line number, let's go line number 15. My first digit is a 7. That would be, I got the 4th toy in the series. Next digit is a 6. I got the 4th toy again. And then a 4. I got the 3rd toy. And then an 8. I got the 5th toy. And so if I wanted to see how many Happy Meals I needed to purchase to get all toys, I would keep looking at digit after digit after digit until I had one in each group, and that would be my outcome. How many toys I would have to look at, how many Happy Meals I would have to purchase to find all toys. Okay, so explain how I will simulate. I'll use table G that's in the back of your book, looking at one digit at a time. Okay. Could I use two-digit numbers? I could. If I wanted to do two-digit numbers, maybe I would go 0, 1 to 10, 21 to 30, 41 to, well, I would have to redo the numbers in here a little bit, but you could use two digits at a time, in which each one was worth 20. So I would go 0, 1 to 20, 21 to 40, 41 to 60, 61 to 80, 81 to 100. Identify the response variable, which is the outcome that we're counting. It would be the number of Happy Meals, in this case, until we get all 5 toys. All right? So if the problem was, how many Happy Meals do you have to buy before you get all 5 toys? That's my response variable, the number of Happy Meals it takes. So if I look at line 15, you know, I might go out 10, 15, 20 toys before I get all 5. That's my response variable. Run several trials of this. You would do maybe 10 to 20 trials of it. All right? And then analyze the response variable. Well, if I do 10 trials and I have a table, you would get a table, or you make a table, trial, and then number of Happy Meals it takes. So let's say trial 1, it takes me 12. In trial 2, oh, I got lucky. I only needed 7 Happy Meals. In trial 3, maybe it took me 10 Happy Meals, and so on. Well, if I'm going to analyze this result, this is my response, what I'm going to do is just take an average of them. And I could say, on the average, it looks like I'm going to have to buy around, whatever, 9 or 10 Happy Meals. You don't want to just use one trial, because the way that random numbers works, sometimes you might get a lot of certain numbers in a row and it takes you a lot longer, or sometimes it might go a lot quicker. But after 10 trials, you'll have a pretty good average of how long it takes. Then you're going to state your conclusion in the context, okay? So, pretending like I did a scenario, from my simulation, and that's what we're stating here, from our simulation, it appears that it might take approximately 11 Happy Meals before I get all 5 toys. So, depending on the context of what you're working with, you're going to take your average and put it into that conclusion. And that is simulation. And when we come in, we will simulate that on our own, and we'll try to see how many Happy Meals it takes us, and each of us will take a different line. So, when you come in, you should have all these notes down, and then we can apply these notes in class when we start. That is Chapter 11, Day 1.